Remember the T-1000 from Terminator 2? That unforgettable villain made of liquid metal could transform its body into anything, a blade, a shield, or even slip through the tiniest cracks. It was the stuff of pure science fiction, a vision that seemed light years ahead of reality. That liquid metal robot could morph, heal, and adapt instantly, a sci-fi fantasy for decades. It captured our imaginations, making us wonder, could machines ever become so fluid, so alive, so endlessly adaptable? We marveled at its shape-shifting abilities, watching in awe as it defied the laws of physics. For years, we left the theater dreaming about a future where robots could change form at will, just like in the movies. But back in the real world, robots were a different story. They were rigid, built for one job, amazing, but inflexible. Industrial robots could weld, paint, or assemble, but only in the exact way they were programmed. The dream of a universal, shape-shifting robot seemed impossible. Engineers and scientists faced endless challenges, and the gap between science fiction and reality felt enormous. But science has a way of catching up to imagination. Every breakthrough starts with a wild idea, and the dreamers in labs around the world refuse to give up. Today, June 11, 2025, we're on the edge of a new reality. Scientists are building tiny robots that can link, change shape, and work as a team. These modular machines can rearrange themselves, adapting to new tasks and environments in ways that once seemed impossible. These aren't liquid metal assassins, they're small, clever machines designed to help humanity. They can assemble into bridges, tools, or even medical devices, working together to solve problems we never imagined robots could tackle. This leap in robotics feels like living in the future. The line between science fiction and reality is blurring, and every day brings new surprises. The journey from movie magic to lab prototype took bold thinking and collaboration. Teams of engineers, programmers, and dreamers joined forces, pushing the boundaries of what robots could be. Instead of building a better robot, researchers reimagined what a robot could be. They asked new questions, challenged old assumptions, and dared to think differently. What if a robot was a swarm of simple parts, creating complex structures together? What if intelligence could emerge from teamwork, not just from a single machine? This shift has opened a universe of possibilities, and we're just beginning to explore what these shape-shifting swarms can do. The future of robotics is here, and it's more incredible than we ever dreamed. So what are these new robots? Meet the M-bots, modular bots. They're not your typical robots with arms and legs, but something entirely different, designed to work together in ways we've only imagined until now. Think of them like Lego bricks. One isn't much on its own, but when you put them together, the possibilities are nearly endless. Just as Lego bricks can be assembled into castles, cars, or spaceships, M-bots can combine to create all sorts of useful machines and structures. Each M-bot is a small, cube-shaped robot. On its own it might seem simple, but its true power comes from its ability to move, connect, and cooperate with others. These cubes can align, attach, and even move as a group, forming larger, more complex shapes. Developed at leading research centers like MIT's CSAIL, these bots are engineered for maximum versatility and robustness. The goal is to create machines that can adapt to almost any task or environment, making them incredibly useful for everything from construction to disaster response. Each cube is equipped with powerful magnets on its faces and edges, allowing them to snap together quickly and securely, much like magnetic building blocks. This magnetic connection is both strong and flexible, enabling the bots to reconfigure on the fly. Inside every M-bot, a high-speed spinning flywheel gives it the ability to jump, pivot, or even roll over obstacles. This unique mechanism lets each bot move independently or as part of a group, navigating complex environments with surprising agility. The real magic, though, is in their swarm intelligence. A central computer gives the group a goal, like forming a bridge or a tower, and each bot follows simple rules to help achieve it. Working together, they can accomplish tasks that would be impossible for a single robot. These robots can arrange themselves into a bridge to cross a gap, a tower to reach new heights, or any structure needed for the job at hand. Their adaptability means they can tackle a wide range of challenges, from search and rescue to space exploration. Unlike earlier modular robots, which were often slow and unreliable, M-bots are fast, efficient, and remarkably dependable. Their design overcomes many of the limitations that held back previous generations. Thanks to their innovative use of magnets and flywheels, reconfiguration is not only quick but also robust. The bots can snap together, break apart, and rearrange themselves in seconds, adapting instantly to new tasks. Watch as the swarm shifts from one shape to another in just moments, responding to new instructions or changing environments with incredible speed. This level of adaptability brings the dream of science fiction robots much closer to reality. What once seemed like fantasy is now being built in labs around the world. The future of robotics is here, and it's modular, flexible, and deeply collaborative. With M-Bots, we're witnessing the dawn of a new era in machine intelligence and teamwork. Where did this idea come from? Nature itself. Nature builds complex structures from simple units. Think of how a single cell becomes a human. This process, morphogenesis, inspired the M-Bot's design. Researchers mimicked how embryonic cells move, communicate, and organize following a genetic code. M-Bots use a digital genetic code, a program to assemble into different shapes just like cells. This is bio-inspired engineering, solving problems by copying nature. The bots' connections are like proteins folding, their teamwork is like ants building a nest. Instead of a central brain, M-Bots use local communication and simple rules just like cells. Each bot follows small instructions, but together, they achieve big goals. This decentralized approach makes the system robust. If one bot fails, the rest adapt. By learning from nature, engineers have created a resilient, adaptable technology. The result, a swarm that can build, repair, and adapt just like living tissue. Let's take a closer look inside an M-Bot and see what makes these tiny robots so unique and powerful. At the heart of each cube is a fast-spinning flywheel. This compact but powerful mechanism stores up rotational energy, acting like a miniature engine inside every bot. When the flywheel suddenly breaks, all that stored energy is released in an instant. This burst of force is what allows the bot to flip, pivot, or even leap into the air. Movements that seem almost acrobatic for such a small device. But movement is just the beginning. Each face of the cube is lined with special magnets, designed to let the bots snap together or detach from each other whenever needed. When two bots come into contact, these magnets lock them into a strong, stable structure, allowing them to build larger, more complex forms together. If a bot needs to move or change its position, it uses its flywheel again to break free from the group and reposition itself, all without any human intervention. The real magic happens when these bots work as a swarm. A computer sends out a simple command like form a bridge or build a tower, and each bot receives a tiny specific task to help achieve the goal. The bots then move, climb, and snap into place, working together like a team of robotic acrobats. They can build pyramids, bridges, or any structure their programming allows. Because each cube can connect in any direction, the number of shapes and structures they can create is almost limitless. They can adapt to new challenges and environments on the fly. The system constantly receives feedback from the bots, allowing it to monitor their progress and adjust the swarm's shape in real time for maximum efficiency. This two-way communication means the bots can detect problems, repair themselves, and adapt their formation instantly if something goes wrong. The result is a team of robots that can build, reshape, and even fix themselves on the fly, constantly evolving to meet new tasks and challenges. It's a new kind of machine, one that's flexible, responsive, and almost alive. With this technology, the possibilities for the future are truly endless, limited only by our imagination. The M-Bot's true power is in action. In one demo, a swarm formed a bridge to cross a gap, then another bot rolled across. They've built table-like structures strong enough to support objects many times their weight. The bots can self-heal. If one is removed, a spare bot fills the gap automatically. This resilience is vital for dangerous or remote environments. The bots can also manipulate tools, forming shapes to grip and turn a screwdriver, for example. These aren't just party tricks. They're proofs of concept for real-world tasks. M-Bots can build, repair, and act as tools, adapting to whatever job is needed. Their teamwork and versatility open doors to countless applications. We're seeing the first steps toward truly adaptable machines. The future is taking shape, literally. As amazing as M-Bots are, challenges remain. Miniaturization is key. Current bots are a few centimeters wide, but medical uses require them to be much smaller. Shrinking motors, batteries, and magnets is a huge engineering hurdle. Power is another challenge. Small batteries don't last long, so scientists are exploring wireless charging and energy harvesting. Coordinating millions of bots is complex. Smarter, decentralized algorithms are needed. Mass production must become cheap and reliable for swarms to be practical. Overcoming these hurdles, size, power, intelligence, and manufacturing, will take years of research. But each step brings us closer to swarms in medicine, construction, and beyond. The journey is just beginning. If we solve these challenges, the possibilities are staggering. In medicine, swarms could travel inside the body, heal bones, patch organs, or target cancer cells with precision. In construction, swarms could build furniture on demand, form emergency shelters, or assemble habitats on the Moon or Mars. For exploration, they could flow into deep oceans or underground caves, reassembling as needed. Their resilience means missions can continue even if some bots are lost. In daily life, personal swarms could reconfigure furniture, clean up spills, or retrieve lost items. Imagine programmable matter, objects that change shape to fit your needs. Your phone could morph into a keyboard, then back again. The future is dynamic, adaptable, and closer than we think. Shape-shifting robots could transform every aspect of our world. The only limit is our imagination. With powerful technology comes serious responsibility. The same bots that heal could be misused to harm. We need strong regulations and safeguards, kill switches, limited lifespans, and reliable human control. Environmental impact matters. Swarms must be biodegradable or recoverable to avoid pollution. Public discussion is essential. These robots could reshape jobs, privacy, and society itself. Scientists, policymakers, and the public must guide this technology together. By balancing innovation with caution, we can ensure these tools benefit humanity. The future depends on thoughtful choices. We've traveled from sci-fi dreams to real-world shape-shifting robots. M-bots inspired by nature can build, adapt, and even heal themselves. The path ahead is filled with promise and challenge. If scientists succeed, these swarms could revolutionize medicine, construction, and exploration. But we must proceed with care, building in safeguards and having open conversations about ethics and control. The future isn't written yet. We all have a role in shaping it. What would you do with a swarm of shape-shifting robots? Let's keep exploring, questioning, and dreaming together.